Welcome to lesson 7, where we're going to be practicing with rational bases and exponents. The criteria to be successful at this lesson is to be able to change an expression with a negative exponent into an equivalent expression with a positive exponent. You also should be able to choose an appropriate exponent rule to rewrite an expression to have a single exponent. We're going to start with a which one doesn't belong. You have 4 different expressions. Take a moment, pause, and decide which one doesn't belong and have a reason why. Okay, so let's go through each of these. There's various reasons as to why you could have picked each individual one, so we'll just go through a couple. This one you could have said that it was the only one where the bases are the same and the exponents are both positive. You could have said this didn't belong because it's the only one where it is a single power of a power. This one you might have said is the only one that has fractions in the bases. And this one you might have said was the only one with different bases. Now, maybe you had different reasons that were enlisted, and that's fine too, but we are going to continue exploring exponents with rational bases. Okay, we're going to start off with some exponents practice with the rules. I'm going to explain how you're going to navigate through this activity, then you're going to pause, and then we will discuss. So you start with this list, and you're only going to choose 6 of the following to write using a single exponent. After you get through with that list, you're going to answer question 2 to say why you chose to skip the ones you did. When you get to question 3, you're then going to choose 3 of the following to write with a single positive exponent. And in the last one, you're going to again pick 3 to just evaluate. Go ahead and pause the video and try for yourself before moving on. Okay, so let's go through the first list. I'm going to just show you what each of these are equivalent to, so you could just self-check the ones that you picked. And then let's talk about some of the ones that some people maybe skipped. It's quite possible that the first one I'm thinking that some of you maybe skipped was letter D because of it being fraction bases. But what you notice is that the rules still apply. So when you look at A through D, all of those are products. And when we apply the rule, we are just adding our exponents together. So A, you're adding 5 and 6 together to get the exponent of 11. B, you're adding the 8 and the negative 3 together. C, you're adding the negative 4 and the negative 3 together. So when you look at D, it's all the same thing, just with that fraction base. So we would be adding 4 and 5 together. Maybe another one that some of you maybe skipped was H. One thing that's come up in some of the other videos is that you have to be really careful when you're subtracting and you have those negatives that you don't make any mistakes there. So in H, you want to make sure that you're subtracting negative 12 minus negative 20. And that is essentially negative 12 plus 20. And so that's where the exponent of 8 is coming from. So E through H all has to do with applying the rule for quotients, and you are subtracting the exponents. I through L. Again, maybe you skipped, I don't know, maybe K. I'm not sure which one maybe you skipped, if you skipped any of these ones. But here we are raising a power to a power, so we are multiplying those exponents together. So for I, 2 times 3 is 6. For J, the 3 times the negative 3 is the negative 9. K, you have a negative times a negative, so this is a positive 32 for the negative 8 and the negative 4. And for the last one, negative 3 and 5, you multiply those together to get negative 15. So you might have had some different reasons, but you should start to notice just some patterns here within the ones that have similar structure. In question 3, you had to choose 3 of the following to write using a single positive exponent. So all of these were written with negatives. These would be all of them written with positives. So again, 2 being raised to a negative power is saying that we are actually multiplying a half by itself 7 times. So it can be written as 1 over 2 to the 7th. And all of those structures are similar for the remaining exponents and bases. So you would apply that same that same rule. The only difference here is we just don't have the powers of 10. We just have different powers that we're using. In question 4, you had to evaluate 3 of these. Here were the evaluated ones. Now, I'm going to maybe assume that most of you picked A, C, and E to evaluate simply because all of those would be then raised to the power of 0, which we know is equal to 1. Now, if you look at B, D, and F, you would actually have to evaluate that by, you can list out all the factors. So like B would be 2/3 times 2/3 times 2/3, which is equal to 8 over 27. And in a similar fashion for D and F. So again, let's just revisit this criteria. This was all about practicing with negative exponents and rewriting things to have positive exponents, and then also being able to choose an appropriate exponent rule to rewrite an expression to have a single exponent. We go into this last activity with inconsistent bases, and we're going to be looking at true or falses. So it might be helpful for some of you to write out the factors. So for example, if we look at this and we wanted to determine if this is a true or false statement, we might list the factors out. So 3 factors of 2 times 2 factors of 5, is that equal to 5 factors of 10? Rearrange that left side so that way we can write factors of 10. So you have 2 factors of 10 times 2, and you still have 5 factors of 10. So we would say that this is not equal. This is a false statement. Now, you might be able to just justify it without writing the factors out, and that's great too. Okay, so take a moment here to go through those 5 and decide if they're true or false. Pause the video and try it yourself, and then we'll come back together. Okay, so this first one we will say is true, especially because we see here that our bases are the same. They're 1/3 on both the left and the right side. So when you apply that rule, we can say that that's a true statement. 4 plus 2 gives us 6. If we also write the factors out, we would see that as well. This next one is false. You have 2 factors of 3, 3 factors of 5. That is not equal to 5 factors of 15. This is also false. You have 4 factors of 5 and 5 factors of 5, and you're adding those 2 factors together. It's not the same as 9 factors of 5. Our next one is also false because of those same reasons if you think about the factors. And the last one we would say is true because you have 2 factors of 3 and 2 factors of 5, and you are multiplying those together. So when you actually multiply that all together, they do equal the same thing. So why is this equation false? Well, because we know that when we apply the rule here, you would be adding the exponents together, and that would give us 8 instead of 15. Let's go here and talk about why is this equation true. Well, it's because when you're subtracting those exponents, 5 minus 2, the bases are the same. We're going to go ahead and say that equals 3 to the 3rd. Why is this one false? Well, look here. You have 5 factors of 6 divided by 2 factors of 3. That is different than 3 factors of 2. And again, just kind of noting the patterns we're seeing here with those bases, and when we apply the rule, those bases have to be the same. That was the rule we came up with in the last video. Okay, so overall in your lesson summary, it covers some of the components we just talked about. This right here was mentioned in the last video, that rule, and how it applies to everything that we did with bases of 10. And just a reminder that your goal for this video was to be able to change an expression with a negative exponent into an equivalent expression with a positive exponent, and then be able to choose the appropriate exponent rule so you can rewrite things with single exponents.